Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super. And today's incident we're going to focus happened on the 29th of May. It was around 5 hours long, and it was for one of the zones in our East-West region. And in one of the zones, we saw some control plane failures. The services that were impacted were Azure Data Factory, Azure Databricks, Azure Synapse Analytics, because all of these take dependency on virtual machines and virtual machine scale sets, and they were also impacted as well.
That's right. This is talking about service management with the control plane surrounding VMs and VMSS, as well as those services Sami listed that depend on it. So to talk us through the impact and our learnings in particular, I'd like to introduce the engineering leaders joining us on our panel today as our guests. First up, we have David Dion, our partner and software engineering manager from the Azure Allocator service, which will feature heavily in our conversation today. And on the end, we've got Ajay Martin Mani as our vice president and engineering manager from our compute team, who's going to help us to understand this issue.
Super. But before we get into the incident itself, David, I was hoping you could help me. My understanding of Allocator, I like to refer to it as the sorting hat of Azure, because it kind of decides as people put in control plane requests or they want things, it decides where things go. Could you give us perhaps a more comprehensive overview than a sorting hat of how the Allocator service works?
Sure. So you're right. The Allocator, to some extent, is the sorting hat of Azure in that Azure data centers have different kinds of hardware. Some support GPUs, some support general purpose, compute optimized VMs. And when a customer wants to run a VM in an Azure data center, then the Allocator has to decide which specific machine in an Azure data center do we put that virtual machine on. So that is the most basic way to think about what the Allocator does. It actually does many other things as well. It is responsible for reporting how much available capacity we have to upstream services so that we know, for instance, whether we're running out of capacity in one zone and we have to go order more. It's also responsible for protecting capacity to make sure that we can heal if we have hardware failures. So there's a lot that the Allocator does, but for customers that were impacted by this outage, it's mainly how we decide which machine to put your virtual machine on. Now, that impacts both creation of new virtual machines, but also updates to existing virtual machines, because sometimes a customer will update the service they're running, and the services that translate what the customer requests to an allocation, they have to somehow validate that the machine you're running on is still okay. You might have changed your virtual machine size. You might have changed something about your network configuration, and we need to verify that where you are right now is still all right. So whether it's a create, it's an update, the Allocator has to be consulted.
Got it. That's a great understanding for us to know kind of the piece that broke here. Ajay, I wondered if you could help us to understand kind of what customer impact felt like, given that the Allocator was having these hiccups.
Yeah. So this issue happened in US East, and US East has 3 different zones. And the issue was in the control plane, which means that service management. So if customers try to create, delete, update their virtual machines, they might have seen failures.
It's specific to one of the zones that you mentioned,
specifically, right? Only one zone was affected, which means that if customers' deployments were going to a different zone or even to a different region, they were not affected in any way. And the other point about the impact is that the virtual machines which were already deployed in the zone were up and running and they were not impacted. So it was only the management of these VMs that were impacted. We talk about this as the control plane and the data plane. And I want to acknowledge that for a lot of customers, our control plane is their data plane, which means when they are trying to create and manage deployments in a fast manner, our control plane needs to be up and available and resilient at the same time. And so in some cases, we did see customers who were trying to do that sort of a fast twitch operations also see failures. So that's where you see Azure Data Factory or Synapse also seeing impact, because they're trying to schedule jobs, and these jobs required virtual machines to be created and deleted, and they saw failures as well.
So it wasn't that there is anything special about Azure Data Factory, they just happened to be impacted because of timing.
That's right, just about timing.
Yeah, I like your point around kind of control plane versus data plane, because when I first started in the comms team, it was very easy for some outages to say, oh, it's okay, it's just the control plane, it's just the control plane. But of course, if you've scheduled for your VMs to come online at 8 a.m. before all your call center team get there, that's now a data plane issue if that
That's
doesn't
right.
happen on time. So that's a good distinction. David, I was hoping you could help us to understand the allocator in a little bit more detail here, because it sounds critical, right? This is underscoring the allocation of every virtual machine. It underscores all of these different services on Azure. Don't we have a backup allocator or a spare allocator, or like what should happen when you think about the different failure modes that could besiege allocator? What's the plan? But before we even get into the specifics of this incident, what should happen?
Yeah, so I think maybe we can talk a little bit about how the allocator is put together, and I think we brought along a picture here that we can use to talk about it. And so what you're seeing here is a schematic on your left, which is the compute control plane that Ajay was just describing. So a customer will enter in through the ARM layer. That's kind of the API surface or the portal surface that customers will see, and then the request that a customer has to deploy some kind of workload into Azure will then flow into what we sometimes call service management services. So they will translate what the customer is asking for into a compute requirement, a storage requirement, a networking requirement, and stitch that together. And then for the compute requirements, they will pass it on to the allocator. Now, on the right-hand side, there's kind of a drill down into the allocator services. I took this picture directly from a paper we published with Microsoft Research a few years ago. And so customers who are interested can follow the link here and go pull this up and get a lot more details on how the allocator is put together. But a few things I'll point out here is that the allocator first is composed by a whole array of these things we call allocator agents. This is where all the complicated logic is contained to determine how we choose which physical machine to place a virtual machine on. We have more than 100 different rules that we're running. We're looking at everything from the health of machines to fault domain requirements to trying to avoid preempting Azure Spot VMs. All kinds of different things we're looking at when we try to find an absolute optimal placement for a customer's virtual machine. We want to make sure that if there is any machine in the giant availability zone, which was impacted here in East US, if there's any machine that can handle that customer's VM, we find it and we make sure that we put the VM on that machine. And we also optimize for all of the other indicators, both for customers and for the platform. So all of that logic is in these allocator agents, and they run on an array of many machines in a large availability zone just to handle the load that's coming in. And those are all resilient to each other. So they frequently will go down either due to planned updates or hardware failures or any number of other reasons. Now, we run what's called an optimistic concurrency algorithm. All right, this is not something we invented. This is a principle used commonly in distributed systems. But the idea is that all of these allocator agents can make decisions in parallel, but then they need to verify that they don't, like two different ones don't make a conflicting decision, something that would yield an incorrect result for our customers. And so after these allocator agents make a decision, they go and they talk to a central thing, a conflict detector and placement store, where we run a transaction to verify the correctness, verify there's no conflict, and then we commit that result. And so we store it so that if something fails, we can remember, where did we choose to put this virtual machine? And so that is kind of the central place where everything flows through. Now, we try to keep that conflict detector and placement store as streamlined, as simple as possible. And even that is a multi-instance redundant service. So everything here is built with redundancy in mind.
Incredible, absolutely incredible to learn how the ingredients of the allocator. What happened in this instance, in this event? What happened? And I'd love to know how you spoke about the piece or the ingredient that failed. How did you detect it? How did you respond? I'd love to know some more.
Right. So as I mentioned before, that conflict detection and placement store, that is committing in transactions every allocation decision we made. And in this particular case, those transaction commits, they all of a sudden stopped working. Right. So when I say stop working, we tried to commit and we hit a performance issue where the commits were taking much, much longer than they were supposed to take. All right. Now, we analyzed the situation, looking at how this could happen. It's a combination of giant load. It's a combination of not throttling effectively. And then there's some kind of hardware failures that are happening on the machine. There could be noisy neighbor issues because we share these machines in this platform with other services. So a lot of things can go into that. But we plan for that. We have to expect that. We never want to come to a customer and say, sorry, we had a big outage because one machine had a hardware problem. Like, that's not where we want to be. And so we have detection automatically to see that these transactions are taking longer than they expect. And as soon as that happens, recovery actions start happening right away. both in the distributed systems platform we use, which is Azure Service Fabric, and also in our service itself. And so in this case, our service within a couple minutes detected that transactions were taking too long, and it immediately started trying to recover. So it tries to aggressively throttle, it tries to fail itself over. And so all these things kick in right away.
These automated repairs started happening. This sounds like goodness, and yet maybe Jay, we
and
can...
yet they didn't work in this case.
Right.
Yeah.
So I think that's a really good way of understanding that initial trigger event and the performance issue and some of the different factors that contributed to it. Jay, I wanted to bring you in here to help us understand this kind of prolonged recovery. Or we mentioned maybe noisy neighbors was one of the examples. Well, what made this outage so as long as it was?
Yeah. So if you remember the diagram from the previous slide, the left side had a whole bunch of applications that were deployed on. And in the control plane, it's not just one or two services. It's actually a group of dozens of services that collaborate together to make the operation succeed. And we do have services that co-locate with other services as well. So in this case, we had services that lead or deal with control plane operations, along with services that help the placement and the logic of allocation happen. Two issues ended up making the issue go longer than we expected. First of all, the allocator did detect that there was a failure and tried to recover and auto-recover. What ended up happening is that the secondaries that the allocator were on also hosted services that ended up taking a large amount of CPU and ended up producing a retry storm or a thundering herd sort of a problem in talking to the allocator. And the reason for the CPU increase was that we were trying to make sure that we don't persist secrets within our logging system. And so we're trying to redact those secrets and persist data into our logs. And so we had a performance issue in the way we were redacting those secrets, and it was happening in line, and it was adding to the CPU usage. And on top of that, we had the allocator pushing back, saying, hey, go back because we're having too much workload happening, and there's a transaction that's taking too long. And so that ended up with more retries, and so more operations coming in. And the performance issue of the redacting was happening because there was a lot of message data coming in as a part of that exception data. And so we did not account for the performance issue of that redacting when the messages were too big. And so a combination of these two started making the issue take longer. And so we went through our playbook. We tried to fail over. We tried to relocate resources off that machine. We also tried to do some level of load shedding. And so all those processes in the playbook took a little more time to get through. And finally, the system that actually ended up working is completely offloading the workloads off that particular service that was creating the load and making another service in the same zone take responsibility of that. And so that kind of helped remove a lot of the load, because that's the only way you can deal with a thundering herd or a load shed issue, is to actually shed the load from the system.
Fascinating stuff. As we pivot towards learning and repairs, David, I'll come back to you. When I was reading the PIR, we spoke about throttling and capacity, but they didn't seem like culprits at the time. Could you walk us through, like, did you just draw a line in the sand and say it's good to harden the service for events that are similar to this, or?
Absolutely. I think that anytime we have an outage like this, we even if we can find, oh, there's one particular bug that caused it, we always look at all aspects of what went wrong. And we always are going to look at throttling. We're always going to look at resiliency through failover. We're always going to look at how our monitoring was, like how quickly did we have the right engineers looking at this problem. So every time we're going to look at all aspects of the problem. And so, yeah, we do mention throttling because every one of these outages is a chance for us to go and see, how did our system behave when something went wrong at giant scale, right? I mean, the timing here of this incident is the peak time in the East US region. And we can look and say, sure, this morning, the East US region did great during the peak time, right? But on this particular day, on May 29th, something went wrong, and how did we respond? So yes, every single one of these is a great opportunity for us to go and re-examine that.
That's great. So I know with some of those repairs we talked about, we're going to beef up our monitoring. Sammy mentioned throttling. We're going to throw more capacity at it. We're going to isolate the allocator to kind of protect it from some of these things. But one of the areas that I really wanted to understand better was testing. One of the questions that customers ask us so often is, well, you're making all these changes. We've mentioned some of the different factors. Can't you test for all of that? Like, how are we approaching either using synthetics or using, fault injection? How do we make sure that we get better at breaking this ourselves?
Yep. It is a constant challenge for us to replicate the load that we see in our largest regions in pre-production synthetic environments. But we keep trying.
We don't have a spare US East that we
We
use.
don't have a spare US East and volunteer customers who will throw load at us. No, it's really challenging for us to replicate the load that we see in our largest availability zones and regions, but we keep trying. And I think that one of the big learnings here is that we need to inject more failures. We need those pre-production environments to be messy. Right? We can verify that things are working as expected. We can throw a lot of load at the problem, but then we need to break stuff, and we need to break stuff in new and creative ways. And so every time we see an issue like this, we say, that's a new and creative way we can find to break stuff. And there are many ways we break services, and we verify that we do recover. This one we had not properly recreated before in our production environment.
That's good to understand. I mean, I know we had a guest on recently, Kirill Gavrilik, who runs Cosmos DB, said the way that we do drills, our drills are just too neat. We come in at 9 a.m. and once the cup of tea is ready, we start the drill. And I like the kind of messiness that you described. Sorry, Sammy.
No, I was going to mention Kirill as well. He left quite an impression clearly on both of us. AJ, I was going to turn to you. When we talk about it was within one zone, it was in one zone within one region. Is there anything customers can do? Like, were all customers impacted if they happened to be in zone one? Was there anything customers could do, or are they just at the peril of allocator and they were just stuck? Like, I'd like to know more about what customers could have done.
Yeah, there are two aspects to it. One is what can we do from the platform side so the customers don't see failures when this sort of thing happens. There are deployments that customers can do where they can try to be zone agnostic. Hey, it's okay, just go to the region, deploy it in any particular zone that you want to. We do fairly good in trying to understand what the capacity usage is of a zone and then decide which zone that deployment should go to. These sort of incidents are showing us that we need to get better health signals to decide which zone we should choose. And it's not like the zone was completely down. We did have success rates. It was not like the failure rate was so low that we could have automatically redirected all traffic to another zone. And so what happens when these sort of limits and thresholds, how do we tweak them and get that health signal to decide which zone we should try to prefer some of these allocations to go to? So that's a learning that we'll be trying to go make better at. From the customer point of view, I always mention that we'd want customers to go into a zonally resilient sort of stature, right? And so wherever possible, try to use zone resilience queues. This is both for data plane as well as control plane operations. So if you're a Cosmos DB, make sure you're trying to use the zone resilient fashion of it. If you're using VMSS, try to be zone resilient VMSS as much as you can. And so following that pattern really helps. The second one, and you see this happening within our system as well, how you manage retries is an important aspect of it. And this is learning for us, and we keep learning, and it's part of distributed systems learning of how do you manage your retry, and customers as well, because in this case, if you had retried, you would have probably seen successes in many cases. But the way you do retries also matters. Make sure that you understand the 429s and what your retry after headers are saying. Try to have an exponential back off, and you don't have to go, do retries too often, because the more often you do, you can get into a retry storm and you end up making the system worse. And so those are two patterns or practices that you can follow.
That's great to hear. I love that we want to take accountability for what we at Microsoft can do to learn and improve, but it sounds like there are things customers can learn from this as well. Retry logic, that zonal resilience, both great options there. So thank you for running us through that. So it sounds like we've got lots of learnings from the compute and allocator perspective. I saved my last question for Sammy, since Sammy runs our incident comms team. Do we have any learnings from a communications perspective? Were we able to keep customers up to date during this incident?
So the way it worked in this incident is we have Brain, which is our automatic notification system. This typically impacts customers within 15 minutes of impact. It typically goes directly to service health, so it doesn't go on our public status page or anything. So if customers did try an operation, then we would say, hey, dear Mr. or Mrs. Customer, you tried this operation, it failed. It's an us problem, not a you problem. And it was great that Brain was firing for this. So if there were customers who were using VMS virtual machines and Azure Data Factory, they wouldn't have two separate tracking IDs. They were being communicated under the one tracking ID, which is a problem we've had in the past. But we were telling customers, hey, this is an us problem, not a you problem. But at some point in time, when we kind of knew a little bit more, we should have got involved. So while our Brain template was still going out, and it was pretty rudimentary, at 10 past 10, after 10 past 10 UTC, we should have told customers what we knew, and we didn't. From around midday, we should have started to offer ETAs, because we did have line of sight about recovering the allocator, and we knew when things were going to get better, and we didn't. And then definitely from around 13:45 UTC, we should have given more meaningful updates. Now, between 2:30 p.m. UTC, between 2 and 2:30 p.m. UTC, we were mostly mitigated, and we saw like a lot of health signals turning well. It was a long tail that dragged us. But again, we should have told customers, hey, we're seeing things recover. You can retry now, and now is a good time to redeploy. And we didn't. So when I look back at it, I think our automation was wonderful, and we're able to tell customers quickly what was happening, but in pretty much record time. But giving meaningful updates about where we are in the incident, it lacked. And so I think that our job isn't just to tell customers it's an us problem, but to walk customers along the way about where we are in terms of detection, understanding what the issue was, and mitigation and line of sight for mitigation.
Right. Yeah, we know the cloud can't be some black box. The more transparent those updates can be, the better. We know customers are making business decisions on that option, and so I love the idea that maybe we could have said, hey, we think we're going to be recovered in 4 hours. You know, we might be wrong. Hiccups might happen. We might not be able to recover it, but at least we're always giving that kind of best estimate so customers can decide. That's really helpful to understand. So learnings from Allocator, learnings from Compute, and even learnings from Com. So thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage, and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.